Okay, so I'm making this video as a guide because we have a drawing engineering graphics project, right? And you have to make things using a laser cutter and then put them together. Now, basically, the simplest way to put them together is with you make a slot in the material and then you'd assemble it, right? Yeah, it's kind of like that, right? Now, the thing is, the laser cutter itself has a thickness, right? Thickness of the laser, and the material itself also has a specific thickness. So you'd have to dimension the hole very precisely. Otherwise, the material would just be either loose, like the connection before I just showed you, or it just won't go in. You can see here I used 2. This hole is kind of small, and you can see it won't go in. Now here's the problem. The piece you see with the sort of the green backing, brown backing still attached is from one shop, and this one is a discarded piece of acrylic left at the laser cutting workshop. What I'm going to show you is that with this sort of shape caliper is that they're not equal. Just so you can see here, the accuracy for small materials under 10 centimeters is up to 0.02 millimeters. So I'm just going to turn it on and zero it. Okay, so I'm going to show you that the thickness of the clear pieces and the thickness of the brown pieces are not equal. So you can see here the clear piece is about 2.89. This is supposed to be a 3mm piece, so you can see there's definitely some sort of discrepancy. Remember the 0.02 plus and minus accuracy. And I'm going to show you a measurement of the other piece of acrylic. So this one goes to about 2.86. Now, yes, if the measurement is off, this can be up to about 2.88, right? And that could be 2.87. So definitely is within bounds. But it is just at least it is important to keep in mind that the piece of acrylic you'll be working with is definitely not going to be precisely 3mm thick. So if you can find access to a caliper, try to measure it first, see how thick it really is. Now you can see I have written these numbers here, and the numbers correlate with the size of the slot I made here, right? In thickness, because it's 5mm down, or at least it's supposed to be. So 2.6, I'm going to show you 2.6. Right, so 2.6 and 2.6. Remember that acrylic is not very flexible, so it is hard to put things together if it's too tight. This piece again is measured out to be just slightly thicker than the brown piece, so keep that in mind as well. So you can see these pieces now fit together very tightly, and I can hold the piece upside down relative to the mating, and it won't fall out. But, a lot of force is needed to put them together or separate them. Now let's compare and contrast a piece with 2.6. Let's see if I can find it. 2.65. So these two pieces have 2.65, and again this is just slightly thinner. I must note I dimensioned these holes perfectly, well, in the laser cutting program. So I put in the dimensions of this piece to be 2.65. The program auto-corrected to 2.649, I think. yeah, 2.649. So that's a very, very small margin of error. We're talking about much less than the possible error in terms of the thickness of the material itself. Now, as you can see with 2.65, the connection is very loose, and if you flip it over, it will just fall out. So we are talking about that level of precision where very small adjustments can make a big difference. The one I'm going to show you is the one I believe to work the best with this particular piece of acrylic, which again is measured to be about 2.86 millimeters, and that is when I dimension hole to be 2.61 millimeters. So you can see it doesn't fall out when I hold it upside down like this, but it doesn't need as much force to separate or put together compared to the 2.6 millimeter. See, it just comes out pretty easily. Another thing to note, actually, is when I drew these pieces, I used the size 20. So these are going to be 2 centimeters across, but when I measure them with my digital caliper, it's obviously when you cut it with the laser takes away some of the material, and it comes out to about 18.6 millimeters. So that's 0.4 of a millimeter that's lost, in total from both directions. The problem is in a different direction, the amount of material taken away seems to be less, and you can see when the width, which was supposed to be 15 millimeters, we got 14.66. Again, if it took away about as much material as it did lengthwise, this should be 14.60. And this is true, basically true for most pieces once I measured them out. I will make a spreadsheet with all the measurements. I'm gonna add all the calculations about the data into the spreadsheet so you can see for yourself, and I'll put the link to the spreadsheet in the description of this video, so you can make some decisions and calculations about your own project.